Hello everyone, this is Foundational Mathematics course and this is Dr. Maha Youssef. Today we will continue speaking about functions. We will discuss the domain of a function, range, plot of linear functions, and the plot of curvilinear function. We will speak mainly today about function of one variable, y equal f of x. Last time we have discussed y equal f of x as a function where x is the input and y is the output. Now, what's the meaning of domain? Domain of a function is the complete set of possible values of the input of the independent variable x. What are the values of x input that will not make a problem with the function f of x? And the question now, what's the meaning of a problem? What could make a problem in a function? Okay, assume we have a fraction. A fraction has a denominator. If this denominator equal to 0, so you have a problem. So you would like to choose all values of x such that the denominator cannot be 0. Again, square root. You cannot take square root of negative number. Why? Because we are living in a real life. We are dealing with real numbers, not complex. Do you remember? So we can just choose values of x such that the term under the root is always positive. Okay, let's take a few examples and discuss it. For the first one, function 2x plus 1. What are the values of x that could possibly be here? Any value. There's no value of x that could make any problem in this term. The same here, x squared plus 1. So x can be any real number. In these two functions, we can say that the domain is the whole real numbers. So x could be any value. So let's go, for example, to 1 over x. We have a fraction here. We have a problem. If x equal to 0, we cannot deal with such kind of function. We say that this function is undefined. We cannot find the value of this function. We cannot define it. So we would choose the domain such that x can be any value except 0. So the domain are the set of real lines except 0. Okay, let's back to this one. Square root x plus 4. I would like to guarantee x values such that x plus 4 is positive or 0, root 0 equals 0. So I would like to choose x such that x plus 4, the whole term down the root, under the root, is greater than or equal to 0. This means that I can send 4 to the other side with negative. So I have to choose x values such that x is greater than or equal negative 4. So I can choose negative 3, negative 2, negative 1, 0, 1, 2, 3, all of these values. But I cannot choose, for example, x is negative 5 because it will give me root of negative 1, which is complex, not real. This is the meaning of domain. Domain is the set of all possible values of x, of this input, and we should have control on this. Assume, for example, you are writing code in computer science. At the beginning of your code, you defined x to be decimal. And then while you are assigning value, and you deal with a function like 1 over x, and while you are assigning value to this x, put x equals 0. It could not be. It could not be. So you have to be aware, if you are defining a variable in your code, what are the possible values of this variable according to the rule of the function. What is the range? Simply, if you inserted the domain correctly, what is the output y? And this, you don't need to think about it so much because you will either get it as an automatic output from the code you are defining, or you will get it from already the graph of the function. So it's not something you could waste time and calculate it by your hand, but domain is the key here. If you define the domain correctly, the range or the values of y or the outputs will come correctly true. Okay, now what is the linear? Linear functions mean x to the power 1. This is the mean of linear. So the general form is y equal ax plus b, while a and b are just constant. And for example, f of x equal to x plus 1, we agreed before that the domain of this function is a set of all real numbers. So simply to plot this function, because this is a line, 2 points are enough. So if we choose x equal 5, we could find that y equal, if we plug here 5, this means that we have 11. So this is 5 and 11. And then the next point, let's take x equal -5. So this is -10 plus 1, this is -9. So we have a point here. And then we just match between these 2 points to get this straight line. Okay, I know before I start this plot that x is real. So the values on x-axis could be positive, negative, or even 0. Let's have a look on the plot now. What is the values of y now, of the output? You can see also the output could be anything, could be any real number. So again, if the function is linear and you are expecting the domain to be the whole real, also y could be any real value, okay? Quadratic. It is one of the famous curly linear functions. Again, we agreed that x can take any real value, but before we plot it, let's have a look here. X could be positive or negative, but x squared is always positive. And we added 1, this means that this is always positive. So if we plotted it this way, this is a plot of quadratic function, we can see from the plot that if x is positive or negative, we have the y is always positive. So the range of the quadratic function means that y is always positive because it comes from the x squared. Root function. We calculated this before, the domain. What makes x plus 4 greater than or equal to 0 is x greater than or equal to -4. This is simply the plot of the root function. Again, we could use Python, we could use MATLAB, we could use any math application to plot such kind of functions. And let's have a look now. X can take from values from -4 up. So this is greater than or equal -4. But if you have a look on the y, you could see that y is taking from 0 from here to the positive. So y is always positive. And you can expect that even without plot. Root of a positive, the output is always positive. Root 4 equal 2. Root 8 is 2 root 2. Root 16 is 4. Root 25 is 5. So the output, what is under the root, is positive, and the output of the root is always positive. Rational. We agreed the problem here if x equal to 0. So the domain is every value on the x-axis except x equals 0. If you went to Python or any math app and we told him to ask him to plot 1/x for us, we will have these 2 blue curves. And we can see that if x is positive, you can see that y also is positive. And if x is negative, y also is negative. And as x will never be equal to 0, we can see from the plot also that y will never be equal to 0. So we can see it also from here. When the fraction equal to 0, when the numerator is equal to 0, but we have numerator here equal to 1. So we never have output here equal to 0. So we never allow x equal to 0 as an automatic from a fraction or a rational function. We will have also y, or the output will never be 0. What I would like you to take from here is only the domain. Why? Because range will come automatically from our code or from the graph we will plot by Python or any math application. If you define the variable in your code, if you define a variable for a function that will come later, take care what are the values could you assign for this variable. You should choose them carefully in a way that it will not make a problem. You will not divide by 0, you will not take square root of negative, and so on. Thank you so much. See you next time.